Alright, hi guys. So today we're going to be talking about solving radicals and rational exponent equations. And before we start that, let's go ahead and do this review problem. So I want to remind you of the principal square root idea, right? So if you already have a square root introduced, right, then the sign of the square root is whatever is already there, right? So like if I have x equals negative square root of 9, well, square root of 9 is 3, so x equals negative 3. If I had x equals square root of 9, then square root of 9 is 3. X would equal positive 3 because inside, on the front, is a positive, right? So if the square root's already there, then you just use whatever sign is in front of the radical, right? So that's called the principal root. If you have an equation, so therefore you have an unknown, right? And then to solve that unknown, you end up having to square root both sides of the equation. Then that's when the result that you get is both plus minus, right? Positive 3 and negative 3. And the reason is because whether you have positive 3 or negative 3, when you square it, you're multiplying it by itself, right? So whether you have a positive times a positive or a negative times a negative, the result will end up being positive anyway. So the way that I remember it is if you have to square root both sides, if you have to introduce that, then the result is plus minus. But if it's already there, you take whatever the sign it is in front. So let's go ahead and simplify this problem right here. Okay, so we have the square root, and actually, let's read the problem. Which of the following values represents the value of all of this when x equals 16? Okay, and they're telling us that all of the values have been rounded to the nearest unit. So you need to round for whatever reason, we're going to round to the nearest unit. So x is 16. So everywhere I see x, I'm just going to replace it with 16. So we have the square root of 9 times x. So x is 16 to the power of 1/2. And notice that this is 9x to the power of 1/2, not 9x all to the power of 1/2. So here, the 1/2 power is only going to the x, whereas here, the 1/2 power would go both for the 9 and for the x. So this would really be 9 to the power of 1/2 times x to the power of 1/2, okay? But since here it's only 1/2 to the x, we're only going to square root 16, not square root 9 as well. Okay, let's keep writing the rest of this. So we have plus 6 times the square root of x to the power of 0, plus 11 times, and again, the 1/4 is only going to the x. So 16 to the power of 1/4. Okay, let's start with simplifying exponents first, right? We have to follow the order of operations. So the index here is 2, so the square root of 16 would be 4. So we have 9 times 4. And then 16 to the power of 0, actually anything to the power of 0 would just be 1. And then 16 to the power of 1/4, so this is 16 to the power of 1, and then the radical index is 4. So we're looking at the 4th root of 16, which the 4th root of 16 is 2. Now, with your calculator, you could do like 4th root of 16 if you don't know that that's 2. I just know 2 times 2 times 2 times 2 is 16, so the 4th root of 16 is 2. Or you could also just do 16 to the power of 1/4, and that would give you 2 as well. So you could do it either way. You could write it as the radical or with the rational exponent. Okay, so 9 times 4 is 36. And the square root of 1 is just 1, so 6 times 1 is 6. And 11 times 2 is 22. Okay, 36 plus 6 plus 22 would be 42 plus 22, which is 64. And the square root of 64 is 8. Again, principal square root, right? So in front of this is no sign, so that means it's a positive, right? So that's why this ends up being a positive 8. So our answer is B. All right, let's move on to today's lesson. So we're talking about solving equations, specifically solving equations that either have radicals or rational exponents, okay? Now, we can solve these equations, right, by transforming them into equations that don't have radicals anymore or don't have that fraction exponent. Now, radical equations have a variable inside of the radical, right? So under the root, you would have a variable there. That's what makes radical equations. So something like x equals square root of 4 isn't a radical equation because the variable is not under the radical. Now, 4 equals square root of x would be a radical equation because under the radical you have the variable. So this would not be a radical equation, but this one is. Now, obviously, you can always rewrite any radical with a rational exponent instead. The index of the radical would be in the denominator of the exponent, right? In the fraction of the exponent. And a very important note to make is that radical or rational exponent equations, they may have extraneous solutions. Now there's the best way to deal with this is just to always check all of your solutions, okay? So here are some general steps. Now these aren't really step by step because every equation is going to be different, but it's just some general guidelines, right? So the first goal is always to isolate whatever radical rational exponent there is, right? So whatever variable with the radical or rational exponent, you want to isolate that. Then you're going to raise both sides to some power. We'll call that power n, right? So we're going to raise it to the nth power. Now, what is n? N will be whatever number is needed so that you can remove that radical or the rational exponent, right? The fraction and the exponent. Once you do that, then you're going to be able to just solve the equation as regular. And very important step at the end, do not forget, always check all of your answers, okay? So let's start with some pretty easy ones, right? So we have x squared equals 5. Now we actually were used to solving this in section 4, right? To get rid of the power of 2, the opposite operation is square root both sides, right? So we introduce that square root on both sides, so our result will be plus minus square root of 5. If we were to plug that in, right, plus square root of 5 or negative square root of 5 squared would give us 5. So these two are good and valid solutions. Looking at number 2, also a very easy one, right? We have the square root of x equals 3. Now the square root of x, remember that index is 2. It's imaginary. You don't ever write that down when it's the square root, but we know that that index is 2. So we're going to raise this to the power of 2, and that will cancel it, right? Whatever I do to one side, if I raise the left side to the power of 2, I don't have to raise the right side of the power of 2 as well. So I end up with x equals 3 squared, which is 9. Now again, we need to verify and check this answer. The square root of 9 is 3. 3 equals 3. That's a valid solution. Let's move on to number 3. This is another one that's very simple, right? You just have one term. That term is the term that has a variable, and you have a power. Now the power is a fraction, right? So what we're going to do is you could change this to look like the 5th root of x, right? Because these two are the same. But there's no need to do that, right? You can actually just power of a power multiplies. So if I raise this to the power of 5, right? 1/5 times 5 will end up being 1. So this will be x to the power of 1, and I would get x by itself. So I'm going to raise both sides to the power of 5, and that will cancel that power, right? So x equals 2 to the power of 5, which is 32. And if you want to check with your calculator, well, you have to check, but if you don't know what 32 to the power of 1/5 is, you can use your calculator, but that is 2. So this is a good and valid solution. All right, let's take a look at number 4, okay? Now with number 4, we actually have multiple things happening here, right? Here's our variable with the rational exponent. It's not isolated, right? We have a plus 3 that we have to get rid of. So I'm going to subtract 3 on both sides to isolate that variable with the rational exponent. So I end up with x to the power of 2/3 equals 7 minus 3, which is 4. Okay, now that that variable is isolated with the rational exponent, I'm going to go ahead and raise both sides to some power. Now the power is whatever is going to get rid of that exponent of 2/3. Remember, power of a power multiplies. So what do I multiply by 2/3 to get rid of 2/3 and make it 1? The reciprocal, right? 3/2. And of course, if I do that to the left, I have to do it to the right. So now 2/3 times 3/2 will be 1. So this will be x to the power of 1. And 4 to the power of 3/2 will be 4 to the power of 3, which is 64, square root, which is 8. Or you could just use your calculator. 4 to the power of 3/2 is 8. And again, you have to verify your solution. So let's go ahead and check this one up here. All right, 8 to the power of 2/3 plus 3, does that equal 7? Okay, if it doesn't equal 7, then 8 is not a solution and we would have no solution for this problem. But let's check. 8 to the power of 2/3 equals 4 plus, oops, wrong thing, plus 3 equals 7. So yes, this is a good and valid solution. Okay. Let's take a look at one more, right? Number 5, okay? Now, this one is a little bit more in depth. We have more than one thing happening inside with the radical, right? But notice that the radical is by itself, right? You have radical 4 minus x. That's the only thing that's on the left-hand side. It's all together already by itself on the left-hand side, okay? Now, if there were other things, adding and subtracting, for example, let's say I had 2 times the square root of 4 minus x plus 3 equals x minus 2. Then I would have to get rid of the plus 3 and the multiplication of 2 before I could do anything, because I would need to isolate that radical, right? But in the example that we actually have, it's already isolated. So I'm ready to go. Once it's isolated, now I need to get rid of that radical. Now this is a square root, right? So I just raise both sides to the power of 2. That will cancel the radical. On the left side, I will get 4 minus x. On the right-hand side, I have 2 copies of x minus 2 multiplied together. Remember, do not just distribute that power. That doesn't work that way when you have more than one term. You have to multiply all of the terms by all of the terms. So I have to multiply x times x times -2, -2 times x, -2 times -2. So x times x will be x squared, -2x minus 2x will be -4x, and -2 times -2 is +4. Okay, now I have a quadratic, so I'm going to need equals 0. So we'll subtract 4 and add x to both sides. Subtract 4, add x. On the left side, that'll give me 0, and on the right-hand side, I'll have x squared. -4x plus 1x will be -3x, and 4 minus 4 will cancel. Okay, now I have this quadratic, and I'm going to solve by factoring. So I'm going to factor out x from both of these terms. So I have x times x minus 3. X times x minus 3 has to equal 0. So that means that x could equal 0, or x minus 3 could equal 0. Now x minus 3 equals 0 gives me the solution of 3. X equals 0 obviously gives me x equals 0. So both of these are potential solutions. Now, why do I say potential? Remember, any of these examples, any of these equations, you have to check the solution. So let's check first x equals 4. X equals 0, sorry. I'm going to check x equals 0 first. Square root of 4 minus x equals x minus 2. Okay, 4 minus 0 is 4. Square root of 4 is 2. 0 minus 2 is -2. Does 2 equal -2? No, which means this solution is not valid. It's extraneous, okay? So that gets thrown out. Now let's go ahead and check x equals 3, okay? If x equals 3 does not work, then we have no solution. So 4 minus x equals x minus 2, okay? 4 minus 3 is 1. Square root of 1 is 1. 1 minus 3, 3 minus 2 is 1. 1 equals 1. So yes, this is a good and valid solution. So our only solution is x equals 3. 0 is extraneous. So if the question was, instead of solve, right, the solution is 3. If instead the question was, are there any extraneous solutions? The answer would be yes, the extraneous solution is 0. All right, let's try a couple more problems together, and then I will give you some time to try a couple on your own. Okay, you're going to do 2 on your own. But let's take a look at these 2. So we have 1a, right? We have 6 times this radical. Remember, you have to isolate the radical by itself first. So how do I isolate? Well, I need to get rid of the 6 that's multiplying. You see how that 6 is on the outside of the radical? So I'm going to divide 6 on both sides to cancel that 6. Then I'll have x square root of x minus 4 equals 48 divided by 6, which is 6. No, 48 divided by 6 is 8. Sorry. Okay. Now that I have the radical by itself, right, square root something equals something. The radical is by itself. I can go ahead and cancel that square root by squaring both sides, right? The index is 2, so get rid of it by squaring both sides. If it was cube root, then I would cube both sides, right? If it was 4th root, then I would put power of 4 on both sides. So that will cancel. We get x minus 4 equals 8 squared, which is 64. Add 4 on both sides. We get x equals 68. All right. Let's go ahead and verify that solution, okay? Now, actually, I shouldn't even circle it first. We don't know if that's actually a solution, right? Just because there's one doesn't mean that it's going to work, okay? So you always have to check it. Anytime you have a radical equation or rational exponent equation, you have to check your solution. So 6 times the square root of x minus 4, does that equal 48? Let's see. 68 minus 4 is 64. Square root of 64 is 8. 6 times 8 is 48. So 48 does equal 48. This is a good and valid solution. Yes, now we can go ahead and box it. That is a good solution. Let's look at 2b. No, I'm sorry, 1b. So 1b, this is a rational exponent equation, right? We have something to the power of 1/4. So that means that it is already isolated, right? Again, if I had instead, like, let's say 2 times 3x minus 5 to the power of 1/4 minus 1 equals 20. Then I'd have to get rid of the negative 1 and get rid of the multiplication of 2 to get this rational exponent expression piece to be by itself. So I would add 1 and divide 2. But we don't have that situation happening here, so we don't need to isolate it. The first part is already done because it's already isolated by itself, okay? So now that it's already isolated by itself, the goal is get rid of that fraction exponent. So I'm going to go ahead and raise both sides to the power of the reciprocal, because then it will multiply to be 1. So multiply by 4 will give you 1. So I'm going to raise both sides to the power of 4. So 1/4 times 4 will give you a power of 1. So we're going to end up with 3x minus 5 to the power of 1, which would just be 3x minus 5. And then 20 to the power of 4, I believe, is 160,000. Okay. So now I'm going to go ahead and solve this equation, right? It's just a regular equation now. So we can add 5 on both sides. So we get 3x equals 160,005. And I'll use my calculator for this part. 160,005 divided by 3 is 53,335. Okay, so divide 3 on both sides. I would cancel that, so we get x equals 53,335. All right, now we don't know if this is actually a good and valid solution, so let's go ahead and check it. Okay, 3 times that solution minus 5 to the power of 1/4, does that equal 20? Okay, now you can actually enter all of this in your calculator at once, right? But I like to go a little bit steps, so I'm going to start on the inside of the parentheses and I'm going to do multiplication first. So 53,335 times 3 is that number, minus 5 is that number, and then that number raised to the power of 1/4, which is really the 4th root. will be 20. So yes, 20 equals 20. This is a good and valid solution. Now we can box it. Let me do a better box. There we go. All right. So go ahead and pause this video and try number 2 on your own. All right. So let's do 2a. Okay, now you can see we have things subtracting and multiplying to our radical. So we're going to have to get rid of that first so we isolate the radical. So let's add 4 on both sides first. So we have 5 times the square root of x plus 13 equals 50. And then we can divide 5 on both sides to get rid of that. So we get square root of x plus 13 equals 50 divided by 5, which is 10. Okay, now we need to get rid of the square root. So I'm going to raise both sides to the power of 2. So we end up with x plus 13 equals 10 to the power of 2, which is 100. And then we can subtract 13 on both sides. So we get x equals 100 minus 13, which is 87. Okay, so let's go ahead and verify the solution. Let's check it. Okay, using the original equation, 5 times the square root of x plus 13 minus 4, does that equal 46? Well, let's see. 87 plus 13 is 100. Square root of 100 is 10. 5 times 10 is 50. 50 minus 4 is 46. Yes, so 46 equals 46. This is a good solution. 87 is good. All right. Last one. Let's try 2b. Okay, we have power here. This is 1/2. We know that's a square root, but we'll just follow the power, right? Multiply by the reciprocal of the power to make the exponent 1. 2x minus 3 to the power 1 would just be 2x minus 3. And then 17 to the power 2, I'm not sure what that is, so I'm going to use my calculator. 17 to the power of 2, 289. And then I'm going to go ahead and add 3 on both sides. So we end up with 2x, not 3, 2x, equal 292. And then divide 2 on both sides. X equals, and I'm going to go ahead and just 292 divided by 2 is 146. Okay, let's go ahead and check it. So check. All right, 2 times 146 minus 3 to the power of 1/2, does that equal 17? Well, let's see. 2 times 146 is 292, minus 3 is 289 to the power of 1/2 is 17. So yes, 17 equals 17 is a good amount of solution. We can go ahead and box it. All right, so hopefully that made sense and this video was helpful, and I will see you guys in the next video. Bye.